we're going to write a method called isPalindrome. Start off with a public static. Later in the problem it says it's a boolean, so public static boolean is palindrome. We are going to want to take a queue of integers. So inside of here, we're going to have a queue, integer, queue. That's just going to be our name. That is our header. And we want to return true if the numbers in the queue represent a palindrome and false otherwise. You can read the rest of this. It's going to describe what a palindrome is, but it's basically whatever it has right here. If you reverse it, it has to read the same as it is in the original order. So let's look at this. We know that we're allowed to use a stack as auxiliary storage. So before we do anything, let's make a stack. We'll call it integer, and we'll set it equal, we'll call it s, and we'll set it equal to a new stack where we have our integer inside of here. This is just how we declare our stack. So from here, what are we going to do? Well, we want to put all of our values in the stack, because remember, queue is first in, first out, and stack is first in, last out. So if we load everything into our stack, right, like let's say this is our queue, right, we have everything in our queue, and then we load this into our stack, then this into our stack, and this into our stack, and then so on and so forth. And then when we pop off from our stack, we're going to go from the reverse order, and we can compare it to the queue, which is in the first order. That's great. So let's load everything into our stack. We're going to do this as long as we have a size of our queue. So let's get the size of our queue. Int size, and we'll set it equal to a queue, because that's what our variable is called, queue.size. Get the size, we'll store it inside of here, and then we are going to want to run through this. So we'll have a for loop. In a is equal to 0, a has to be less than our size, and we'll just do a plus plus. So inside of here, we're going to want to go into our stack, right? But we also need to remove the values from the front of our queue so we can look at the next value. So that means we're going to want to remove the front value of our queue. We can add it to the end, and that's going to be okay because we have a specific size length that we're running this for. We're not going to keep running over itself. We'll have int, and we'll call this temp, and we'll set it equal to a queue dot remove, because we want to remove this value, right? And what we can do is put that in our stack, and we can put it back inside of our queue. So once it's in here, we're going to do s.push, where we push in our temp, and we can also do a queue.add, where we have our temp added in like this. Another way that you can do this is, instead of storing it like here, you can push a queue.peak. This way you remove the front variable. Well, you don't actually remove the front variable. You look at the front variable and then you remove it. And then here you do your actual queue.remove. And that just saves you a line of code. So hopefully that makes sense right there. That's just essentially adding everything into our stack. Now after we do this, we are going to want to look through our stack and compare to what is in our queue. So and we're going to run this as long as our stack is not empty. So once it's empty, it's going to stop running, be popping it off every single time. We are going to want to look and compare. If they are not the same, we want to return false. But we can't return false immediately because we need to restore the queue into its original order. So we actually have to run through the entire queue. So let's make a variable up here, boolean answer, and we'll set it equal to true originally. And we can have a condition in here where it says if our s.pop does not equal to our queue.peak, because we only want to currently look, not remove, but look at this first value right now, we are going to set our answer equal to false. So from here, we've already popped off of our stack, so we're ready to look at the next one. After we do this, we just do a queue.add and then a queue.remove again, so we can add to the back of our queue. And this is fine because it's going to run until our stack empties out, which is our entire queue. So that will run through the whole thing. And then we're just going to want to return the answer, which is either going to be true if we don't have any issues, or it's going to be changed to false. So we can close off our method. This is the code that I would use to solve for a problem that's like this. Hopefully that helps you out with the stacks and queues. If you have any questions, as always, leave them in the comments below. It'll pass your 10 out of 10 tests, and that's how you do 14.8, which is palindrome.